But yeah, hi, I'm Jamie. I'm a senior software engineer, also in CareTech. I have a website. It is very much my personal brand to push it in everyone's faces. You can also see it in the background there. And without further ado, let's talk about what we're here for, which is OpenAPI. So you may have seen there are some stickers around. They're from the OpenAPI initiative, which is really awesome because they don't usually send out swag. So big thanks to them. And yeah, I'm going to talk about how we ended up shipping services much more quickly using design first approaches. So before we get started, let's actually talk about what is OpenAPI. So you've potentially already heard of this under the name Swagger or OpenAPI. And Swagger is the old version that OpenAPI came out of. It was originally backed by a corporation, and now it's an open standard with an open initiative running it. OpenAPI is an awesome thing, and that is because it is a machine readable and fairly human readable format for documenting APIs, and in particular their contract. So you don't need to read all of this, but the main thing that's important here is there's some metadata here for what is the API. So things like the version, some information around like what is the name of the API, what's the description. But also in a lot of cases, especially internally, where you've got tons of APIs, but also externally when you're interacting with like a partner API, you want to know how to get in touch. You want to know like what the license is, if there's any code available. And you also want to know like, where is it? What's the URL? So OpenAPI is a standard for marking that up. You can write it in either YAML or JSON. I personally prefer YAML, but yeah, whatever you want, really. And the idea here is that you document all sorts of things in it. So this is just some of the generic metadata, but you can also actually document all of the paths. You can manage things like how you do authentication and authorization. And the perks of it being machine readable is you can do lots of things after that. So we'll talk about that in a second. So OpenAPI, why would you use it? Well, it's currently like the de facto standard for RESTful APIs. There are a few other standards for things like GraphQL, gRPC, and asynchronous APIs using things like async API. But for RESTful APIs, OpenAPI is kind of one, and it's got a massive market share, and there's a load of tooling that we'll again talk about in a second that is really beneficial for use just getting on. The other thing is it helps reduce boilerplate. So by taking advantage of some of these tools that, again, we'll talk about in a second, you can get rid of a lot of the boilerplate. So I don't know about you, but the number of times I've gone to start a new service or add a new endpoint to a service, and you have to write a load of code, which is, if this optional parameter is not present, then do this. If this required parameter is not present, throw an error. If this required parameter is not present, throw an error. It's just like, it's not really the most important part of the job. It's not really the distinguishing factor of whether we like ship a service that is good for our customers or not. It's the sort of thing that you need to do, but it can be automated. It's, yeah, boilerplate. The other one is by using things like OpenAPI, it makes it much easier for people to write API clients. Now, you could do that by hand, but again, because it's all machine readable, you can actually generate API clients. So you won't even have to write a line of code to be able to understand all the inconsistencies and weird design decisions that someone else has chosen. You can just get all the code generated for you in your language, and generally also like in a framework sort of way that you would want it. It also, longer term, allows you to start looking at like API design enforcement. So if you want to start like standardizing the APIs you've got, understanding how different people do different things, if you have everything in a consistent format that is well standardized and well supported, you can very easily make some investigations on top of that and actually enforce things as well. So you can put in requirements for, oh no, headers have to all be lowercase, which is a bad example because they are anyway. It's fine. But yeah, you can do other things. It also, and this is where we got a lot of the benefits from was you can do something called design first API development, which is thinking about the design up front, most likely writing it in OpenAPI and doing some other stuff with it, but generally thinking about what you want to do up front. So instead of going to write a load of code and then like a week later, you finally go and integrate with it and it's like, oh yeah, that doesn't have like any of the things we needed. Or you realize that, oh, we've added like 7 required parameters that aren't actually ever going to be given to it. So you can save yourself a lot of time and effort. And you can also, in my opinion, it works a lot like test-driven development. It doesn't have to be like a thing that you quite militantly do and you enforce, but it's something that you can play around with. You can use as a guiding factor for how do I want to better ship and develop this thing. As I mentioned, there's also a ton of tooling. So openapi.tools is a little microsite that has a load of things that are supported and well developed in the community. So one of the things we did on the care request API, which is where this is all coming from, is we generated almost all of the server code. A lot of the boilerplate was generated out of just one YAML OpenAPI file. We also wanted to integrate with another service. So at that point, we actually retrofitted some OpenAPI to that service, and then we could generate a client. So again, we had to write very little code, and we could focus on actually trying to solve the business values rather than focus on, oh, okay, if this HTTP header is set, then do this, which, yeah, it needs to be done, but it doesn't necessarily need to be done by us. You can also do things like create like dynamically serving HTTP servers that can produce like mocks instead of you having to write them yourself and think about all the different values. And the great thing is, because it bases it on your OpenAPI document, you can actually find issues in your spec. So we found one where we just said, oh, it'll be any character. In like a request status, we'll give you any character as a string. And in fact, we then realized that because the mock server is clever, it said, okay, I'll give you a load of emojis and I'll give you random characters that you probably aren't expecting. And it ended up breaking some of our tests. And it's things like that, that by using tooling to think of things that you couldn't even think of, because you're probably thinking happy path stuff instead of actually abiding by the contract, you miss out on a lot of stuff. And the other one is not everyone likes reading YAML. And especially if you have people who aren't necessarily developers or like super technical and understand the intricacies of YAML, and but especially if you have things like YAML anchors, which I think most people are probably like, that looks really weird and I don't like that. So there's things like that that you can turn that nice, not so nice YAML document into a pretty nice looking documentation site. You can use it to augment like developer portals. So while working alongside like technical writers, you can create like a really nice experience for your consumers. You can also catch breaking changes sooner, maybe. It depends on the tooling you've got. In Go, which we've been using, I happen to have written a library that delegates a lot of the work to someone else. But that sort of thing helps us catch breaking changes in our OpenAPI before we even ship them and make sure that we are actually testing things accordingly. So it's like the perfect time to do this when you're starting a new service, and this is what we did. We're building this thing called care request API, and we wanted to ship it as quickly as possible because we had a deadline. And in this case, I came in with some experience of OpenAPI and I was like, let's do it. And we ended up generating hundreds of lines of code. It simplified a load of the work, and that was really great. But we're not always working on new stuff. And sometimes you have to retrofit because everyone's got existing code. And the second best time to do it is right now, and retrofit it as you can. So this is an example of an open source project where We're using a Ruby gem called committee to introduce retrofitted OpenAPI tests. So in this case, we're getting an error because we've returned an array of objects, whereas the OpenAPI spec says it's an object. And it's things like this that you can slowly crank that in. You can do it endpoint at a time until you finally have a fully documented server. And then from there, you can do things like integrate with other services more easily and generally have a nice time. So what does that actually look like? I'll talk to you for about 10 minutes now, but I haven't actually shown you like an example of what it looks like. So we're going to take this from the OAPI code gen tool, which we've been using and have had a lot of good experience with. And the code snippets are from an open source repo that I've written and are all Apache 2 licensed. So the first thing you start with is once you've got your OpenAPI YAML file, you also create this one. And this allows the generator to tweak some things. So we want to generate an HTTP server using the Gorilla Mux library. We also want to generate the HTTP layer objects, and we want to embed the OpenAPI spec in the file. So this then allows us to generate all of the HTTP objects. Now, this is amazing because I'm fairly new to Go, and I really dislike the fact that, so for instance, if you look at the care request struct, to have an ID field in that JSON object, you have to capitalize the ID, but then you have to have that JSON tag where it's lowercase. And if you're handwriting this for potentially hundreds of objects, well, who's got time for that? It's awful. So by being able to generate this, you don't have to think about it. And even when you define things like a UUID type in your OpenAPI, it can then actually generate you UUID types. There are some internal identifiers that we have at Deliveroo. And again, using our OpenAPI, we can use an extension which says use this type, and it will then generate code that just uses that type. It's really powerful. This then, we then have this thing called the server interface. This is an interface that you just need to implement. You'll notice here that on the getRequest method, we have a request ID and a params object. Now the request ID is taken from the path of the URL. So again, this is all generated from our spec. And you notice here that this also includes a tracing ID, which I realized I didn't actually have a sample of the OpenAPI, so sorry. But this gives you an example of it's giving us a nicer interface. So usually if you're writing this code, you would just have the two first parameters, the response writer and the request, and you would have to manually parse everything. But because we've auto-generated this, under the hood, the code has actually generated a load of things which says, get this path parameter, get these parameters from like the headers and the URLs and everything. And then you need to write the simplest piece of code. So then use simply create a struct that implements that interface. And then in there, you just focus on the HTTP logic that is important to that method. And don't worry about how things get in and out. Which then leads to this. And again, you don't need to read it in full. I realize it may not be the right size on the pitch. But the idea here is that you don't need to focus on how do I get that thing out of the URL? How do I get that thing in a header? It's simply delegate to the business logic and then return a response. And the thing that we found was really nice with this is it definitely means that you can avoid writing a lot of business logic in your endpoints because it's all architected around don't do that, and helped us retain like a much nicer domain boundary between all our things. Finally, you can also add tests for this. So as mentioned, there's also a library that I've written which helps enforce compliance. So you actually get test failures if at any point your request or response doesn't match the contract. So it's a great way of giving you that TDD feedback as well as other tests that you write to make sure that it's all working. And then to actually hook it in, it's fairly straightforward. You just create a new version of that struct, and then call some generated methods and add some middleware, which makes sure that on the actual running server, it enforces the contract for consumers as well. And that's it. Like it simplifies a load of things. And yeah, so just to quickly recap in the 30 seconds or so I've got left, which I'm currently burning through talking about this. So we've got OpenAPI is great because you can write fairly human readable docs that is machine readable. The perks of it being machine readable is you can get a ton of tooling that can do some really awesome and powerful things. So you can do stuff like visualizing the docs for either humans or machines. You can better build and test the APIs. Something one of my colleagues mentioned yesterday is you can also like diff between OpenAPI contracts. So you can find out what has actually changed if you don't want to have a look at the raw YAML, which is really powerful. And also, like, just having a specification, whether you do it design first, as I personally like to do, or whether you have to retrofit it, either way, you've got more documentation, it's more standardized, and it's better in general. And I've got some further reading. So there's a blog post on the Deliveroo engineering site, which I'd love for you all to read. It goes into a bit more detail. There's also a blog post on my website, which I hope I see lots of hits to, where we go through that full example a little bit more, and then the code for that. So I think that is me. Thanks for having me.
Thanks, Jamie. I feel you need to stand up a bit more. Now we can see the URL to your website. There it is. All right, so we have a couple of questions. I'm not going to sit down for this because it will look a bit silly if I'm sitting down by myself. So I'm just going to stay here and I'm going to read the questions. So first question for you, Jamie. How do you deal with different REST API generators for OpenAPI, which only supports subsets of the spec?
It's a really difficult one. And again, we were very fortunate that in Go, the generator that we've got supports a lot of stuff and it's very modern. But so one of the ones we used in Ruby doesn't support the newest version of OpenAPI, which is about 18 months old. So things like that, but depending on who's maintaining the libraries, you may not get good support. So unfortunately, then you have to play to what is the minimum bar that we're comfortable with. So if you've got a load of consumers that you know are in Ruby, you may have to only use OpenAPI 3 instead of 3.1.
Nice. Okay, next question at the top is, can you talk about OpenAPI versus gRPC? gRPC, sorry.
I don't really have much experience against gRPC, so I'm not even going to pretend to waffle an answer. But I'm sure we do have some people at Roo who have some great answers.
Just send us a message and we'll figure it out. All right, next question. How do you deal with different REST API generators for OpenAPI, which only supports subsets of the spec?
Did we just do that one? Maybe a duplicate.
Oh, did I read the same one again?
Yeah.
I don't know, they keep moving. Sorry, yeah, it disappeared now. Sorry about that. How do you handle API versioning when working with OpenAPI? Do you have to have multiple schemas?
Ooh, so versioning is one of those topics that can be quite divisive. So you don't have to, depending on which versioning scheme you use. So if you do something like content type negotiation, you can do it all within one contract. If you do it with like paths, so /v1/requests, you can do it in one file, or you can split it over multiple files and you can then bundle them together. So it gives you that control where if you want to break down a giant file into multiple, you can, but you can also have it all in one, and it doesn't cause any issues.
Cool. So I have one more question for you. What's the next big thing for OpenAPI, or would you consider OpenAPI fairly complete as it is right now?
I wouldn't say it's complete, and especially while we don't have like widespread support. Like as I mentioned, we don't have all of the languages or all of the primary used languages supporting OpenAPI 3.1. So I think until that's done, can't really call it good enough. And then there are changes going into, I think it's OpenAPI 3.2 that will change a little bit more. But I think like right now, OpenAPI 3 as it was, and even though Swagger or OpenAPI 2 was pretty good for most of the things you needed. With things like 3.1, we now perform like actual JSON schema. So it's now a real JSON schema, not an OpenAPI amalgamation. There are things like webhooks. So I would say it's probably getting close to feature complete, but we'll see what happens.
Okay, we have 3 more questions now. People keep adding things. So is it worth going for Swagger Premium?
I don't know what Swagger Premium is.
Anyone in the audience want to complement the question? I guess no. All right, so then the last question, how do you share the API documentation between teams?
So this is something that we are actually in the process of changing. But the primary thing is available in internal GitHub repos, so people can just go and browse it. We also have a documentation site that runs internally for Roo. And through there, it actually auto-populates OpenAPI and Swagger documents from across our GitHub repos. So you have a central place to go. And then what we're also looking at doing is building a slightly better pipeline for that. It also adds in some validation and surfaces it in some of our other tools. So things like when you go to a deployment, you can see, oh, okay, 3 new endpoints were added in this release, and stuff like that.
Nice. Okay, so I think that's all the questions that I have for you. Thanks so much, Jamie.